Hello and welcome to this video. In this video, we are going to look at how to calculate the voltage, the number of turns, and the current that is passing through a transformer. Don't forget to subscribe to our YouTube channel and the Facebook page, Zuluga Consultants, for this and more videos. If you find this video very beneficial, please don't forget to share it, like it, give us the comments. We love the feedback that you give us. So let's look at what we have here. We want first to look at how to calculate the voltage in a transformer. So usually a transformer has the primary coil and the secondary coil. So these two coils have different inputs and outputs respectively. So in this case, we have been asked to calculate the voltage in the secondary coil. So they are asking us to know what is the voltage that is coming out in this transformer. So there is a good relationship between number of turns and the voltage that the transformer gets in or gives out. The relationship is this: the voltage in the secondary divided by voltage in the primary is equal to number of turns in the secondary divided by number of turns in the primary. So when you look at these four variables that we have here, you'll notice that the question has given us three of them. The fourth one is what we have been requested to do. So this simply tells us that we need to put these values in our equation. Now, as you are putting in your equation, you need to counter check the figures, because if you make a mistake on how you put the values in this expression, the answer changes. Look at what we have been given in the question. The question is asking us to find the voltage in the secondary coil. We have the voltage in the primary coil, which is 12 volts. So we'll put 12 volts there. And then we come to the other side of our equation. We have the number of turns in the secondary. The number of turns in the secondary is 25 turns. So 25 turns there. And then the number of turns in the primary, it is 100. 100. So when we put these values, you counter check. So primary coil voltage, you confirm it's 12. Secondary number of turns, you confirm it is 25. Primary, the number of turns, you confirm it is 100. If this is correct, you can now continue to solve your question. So we cross multiply there. We'll have the secondary coil multiplied by 100 is equal to 25 times 12. Now here we have secondary coil multiplied by 100 is equal to, when you multiply 25 and 12, we get 300. After you do this, you divide both sides by 100 so that you get the value for the secondary coil there in terms of the voltage. So when you divide 300 and 100, so 100 into 300 gives us 3 voltage there. So the voltage is 3. Look at now the second example. In this second example, we want to answer two questions. That is, the first one, we want to calculate or to find the number of turns that are in the secondary coil. Then thereafter, we'll calculate the current flowing in the secondary coil. How do we calculate the number of turns that are in the secondary coil? The relationship that we have is the voltage in the secondary coil divided by the voltage in the primary coil is equal to number of turns in the secondary divided by number of turns in the primary. So when you have this, the option we can use is to make what we have been asked the subject of the formula. So in this case, we have been asked the number of turns in the secondary coil. So let's make that the subject of the formula. You can simply cross multiply there. We'll have number of turns in the secondary multiplied by voltage in the primary is equal to voltage in the secondary multiplied by number of turns in the primary. Then you divide both sides by Vp by Vp. So when you simplify these two, you will have number of turns in the secondary is equal to Vs multiplied by Np divided by Vp. So if we have this now, we can put the values of what we have in the expression. So what is the voltage in the secondary? The voltage in the secondary is 220. So we are saying 220 multiplied by what is the number of turns in the primary? The number of turns in the primary is 400 divided by the voltage in the primary. The voltage in the primary, it is 110. So this should give us the number of turns in the secondary. So when we multiply 220 and 400, you get 88,000. This is being divided by 110. So if you divide 110 into 88,000, you should get 800 tens. So this becomes the number of tens that are in the secondary coil. Let's look at the next question. Next question is asking us to calculate the current that is flowing in the secondary coil. So how do we calculate the current that is flowing in the secondary coil? So the relationship that we use is the voltage in the secondary coil multiplied by the current in the secondary coil is equal to the voltage in the primary coil multiplied by the current in the primary coil. So this relationship should help us to calculate the current that is in the secondary coil. So we are being asked to find this, so we can simply make the current in the secondary coil the subject of the formula by dividing both sides with Vs. So we multiply, or we divide both sides by Vs, we simplify this, then you have the current in the secondary is equal to voltage in the primary multiplied by current in the primary divided by voltage in the secondary. So let's put the values in this question. What is the voltage in the primary? The voltage in the primary, it is 110 volt there, multiplied by what is the current in the primary. We have been given it is 10 amps. Then divide by the voltage in the secondary, which is 220. So 220 volts. So you will notice this V and this V will go, then we'll remain with the A as the unit for the answer. So we are simply saying we are dividing the 1,100 when you multiply 110 and 10, divide by 220. So this is in A. When you divide the 2, you have 5 amps. So 5 amps becomes the current that is coming out or produced by the secondary coil.